Hello everybody. Today I found this interesting problem and I was trying to see if we could solve it together. The problem goes as the following. How many times do you have to fold a piece of paper so that it reaches from Earth to the moon? Okay, so it might seem strange at first, but let's think about it. So we have one piece of paper and we fold it in half. Now suddenly the thickness of the paper becomes twice as thick, right? And if we fold it again, instead of 2 layers, we will now have 4 layers. Fold it again, then we have 1, 2, 3, 4, 5, 6, 7, 8, and so on. So first let's figure out an equation that relates the thickness of our paper to the amount of times it's folded. So I'll just create a small table here. So fold and thickness. So we've seen here, if we fold it once, our thickness will be 2 times the normal thickness of a piece of paper. And for this problem, we are going to assume that a piece of paper will have a thickness of 0.1 millimeters. Okay? So our thickness, if we fold it once, will be 2 times 0.1. If we fold it twice, our thickness would be the original thickness of the piece of paper, which is 0.1, times 2 times another 2, since we fold it in half, double it again. And now same thing when we fold it 3 times. Thickness would be our original thickness, 0.1, times 2 times 2 times 2. So do you see a pattern here? Is there a way we could simplify this? So when we fold it twice, 2 times 2 we can rewrite as 2 squared. And 2 times 2 times 2 on the third fold we can rewrite as 2 to the 3. So the number of folds will be the exponent for our thickness. So that means that any number that we want to get of folds will have a thickness of 0.1 times 2 to the power of that number. So here you can see that the number of folds corresponds to the thickness, since it'll be the exponent in it. So now we want to figure out how many times do we fold it to get the distance from Earth to the moon. So first thing we need to know is, what is the distance from Earth to the moon? So you can look that up, and the distance would be 384,400 kilometers. Alright? So notice one thing here. Here our unit is kilometers, while our piece of paper is in millimeters. So we need to convert our distance from Earth to the moon in order to match into millimeters. So we can multiply this distance by 1,000 to get the value in meters. So that'll be 384 million meters. And now there are 1,000 millimeters in a meter. So multiply that by 1,000 again, and we will get this value here. Okay. So now we want to use the equation that we found, 0.1 times 2 to the n power, and equal that to the distance from Earth to moon in millimeters, which is this value here. And now all we have to do is solve for n. So first things first, we have the 0.1 on the left side, so let's get rid of that. So divide that out. And now I know we will have a big ugly number again, but feel free to use your calculator for this. And I'm going to write it in simplified form. It will be 3.8 0.844 times 10 to the 12th. And now we want to solve for n, but our n is an exponent. So how do we get it out of the exponent? We use a log function. You can use any log function. I'm going to use ln because that's the most common one. So I'll just ln both sides. So how does this help us? Well, there is a certain rule in the natural log function that says if you have a value in a natural log with an exponent, we can take this exponent, in this case the n, and transfer it in front of the natural log. So we can move the n in front of the natural log. So we'll get this n natural log of 2. And see our natural log moved here. And our right side, our right side can stay the same. So now all that's left to do, solve for n. We'll just divide natural log of 2 over this big thing here. And feel free to use a calculator because I am. So our value for n will be 41.8. So that is theoretically how many times you must fold a piece of paper to make it have the distance, or the thickness per se, of the distance between the Earth and the Moon. I hope you found this problem interesting. Thank you for watching, and I hope you enjoyed this video. And I will see you guys next time. Bye!